Today's first question, well, everyone knows it's supposed to have these integration formulas already on the homework. The good news is I will be showing the formulas for all the questions that we're about to attempt today. So there's no need to take down this screen, but you will need it for this particular question. All right. So this particular one, I'm going to ask you to, you won't be able to send your answers. I think this one might be a little too complex to type on the chat, but if you want to attempt to send the answer, feel free. If it's too difficult to send the answer, just let me know that, hey, you're finished with the question, so I will know when to start working it out. All right, so get started and good luck. If we are integrating this expression, I think I will run to this particular formula here. When you integrate sine, you get minus cosine, and whoever is touching x goes underneath. So when you integrate this, you will get minus 7, but the 5 goes underneath. The sign changes to cosine, but you are left with the 5x plus 2. That does not change. And when you integrate a constant, you just add in an x over here. And then after an integration without limits, you have to put plus c. Right? For those who just said you finished, please verify with me that if you got this answer. And for those who submitted answers and had this, congrats. Okay, make sure you have this minus sign here. A lot of people may have forgotten the minus sign by mistake. Right, take 10 seconds and we're moving on to the next question. Question 2. No, not question 8. Well, slide 11, but question 2. All right, so let's try this one now. Remember, there's a small little hint. Remember, when you're integrating x is really x to the power 1. Just nobody just put the power 1, right? So just be a little careful with that one. But let's give you a quick, let me just give you a quick shortcut in maths. If you have 1 divided by a fraction, let's say 5/3, right? It's not often you see a fraction underneath a divide sign. But when you simplify this, the fraction, when you bring it on top, it is get flipped. So you see 5 on 3 became what? 3 on 5. It's also not a good idea to leave a fraction underneath a fraction. Like you always try to bring it on top, and when you bring it on top, you flip it. Even though both are mathematically correct, I think the examiner will appreciate you throwing it on top for the final answer. So let's try this question here. Remember we said x is really x to the power 1. So when we integrate this part, we add 1 to the power because we're integrating, and then we divide by the new power. So it's x squared divided by 2, right? So, okay, I think the person who was sending the answer, and I think I understood what you were trying to do. X squared on 2 is the same thing as a half x squared. So I don't know if you were trying to write a half x squared and it was just looking funny on Zoom. But both of these are correct. All right, so now for this one here, when you integrate cosine, regular boring cosine, you just get regular boring sine. But it have a minus sign here, right? So it have a minus. Integrate cosine, you get sine. Whatever is inside the brackets, it remains the same. But when you throw whoever is touching x, you have to throw them outside, but it goes underneath. So you're getting a 3 on 2 like that. Don't leave it like this, okay? 3 on 2 underneath a 1 just looks funny. I think you should throw it on top. And of course, the 3 on 2 will turn to 2 on 3, or 2/3, right? Plus C. How much of you all had my answer? All right. All right, so this one is a little bit more complex, but the good news is you just integrating everybody separately. Don't look at everything at once. Integrate him, then integrate him, and then integrate him, right? 3 short steps. So let's start off with the 1, right? When you integrate 1, you're going to get x. I think we know that one already. Plus, when you integrate cosine, you get regular boring sine, right? Integrate cosine, you get positive sine. But who's touching x here? Remember, x on 2 is the same thing as a half x. So if I ask you who's touching the x, then it's the number or fraction a half. So that means when we integrate cosine, we get positive sine. Whatever is in the brackets remains the same. So we just put back the x on 2. But whoever is touching x goes underneath a 1. It goes underneath. So it's 1 divided by a half. And a half was touching the x. You cannot leave that green answer looking like that. It looks untidy. So you throw the half on top. And when you throw the half on top, you'll get 2 on 1. But we all know 2 divided by 1 is still what? 2. So this mess over here, we can clean that up and just put regular boring 2. All right. So for those who forgot the 2 here, I hope you see your error there now. The next one, when you integrate sine, you get minus cosine. Also, if you ask who is touching x, minus 1 is touching x. Just nobody's going to put that 1. So you have a minus sign here, right? That is this minus sign over here. When you integrate sine, you get minus cosine. So you all see what's going to happen here already. 2 minus signs are going to do what? Touch, right? I'm going to put a little space here. So you get minus cosine. Whatever is in the brackets, you leave it there. And who's touching this? Minus 1. So that minus 1 goes underneath a 1 here. And remember where this minus sign came from. This minus sign came from the integral of sine. We have a kind of weird situation here because the question came with a minus sign. When you integrate it, you get a next minus sign, and then you have to divide by minus 1. A minus and a minus is a plus. A plus divided by a minus is a minus. So this whole mess here boils down to a minus. 3 minuses give you back a minus. So this whole thing will boil down to this. And then, of course, well, I run out of space, but I'm already supposed to put plus C afterwards. For those who made a mistake, do you see the mistake? Now, most people made the error with the minus here. They had a plus sign here by mistake, not realizing it was 3 minus signs coming together. Right? All right, so take a 20 seconds and we're moving on to the next question. Clear this. All right, so we did 3 questions there on the integration of trigs. Now, that was just a kind of brief intro. Usually, well, eventually the integration of trigs will be mixed into regular boring numbers, like just x or x squared and everything just now. Now we are going to integrate with limits. Limits is when you have 2 numbers, one on top and one underneath. But whenever you're integrating limits, you're already finding the area underneath the curve of the equation. I'm gonna have to ask everyone to submit answers for this one now. So I want you all to integrate this question where the limits are 3 and 1 for x squared, right? You're setting only the final answers. And keep in mind, whenever there's limits, your answers will not have a plus c. Color 1. So when you integrate x squared, you're going to get x to the power 3. And you divide by the new power. And then you put your little square brackets like this. What you're going to do is put the top number in, then the underneath number. When I say put it in, you're going to replace all the x's with the top number, then replace all the x's with the underneath number, and then minus both answers. So when you do that, it should look something like this. We get a different color. So this x, you replace it with 3. So you get 3 to the power 3 divided by 3. You must put a minus sign after, and then replace all the x's with 1. So how is this going to look now? 3 to the power 3 is 27 divided by 3 minus 1/3. You're going to get 26 divided by 3, or 8 and 2/3, or 8.666666. Then you have to put the words units squared. Because remember, whenever you're finding the answer for limits, you're already finding area. And what is areas measured in? And either centimeters squared or meters squared. So you put units squared to get full marks in the exam. All right, so I don't think I saw only one small wrong answer I saw, and somebody had 8 and 1/3 by mistake. No, not a huge error. For those who got it wrong, did you see your mistakes? Let's look for something a little bit more difficult here. How about this one with a minus power now? Let's see what you come up with. All right, so we have to add 1 to the power. So the minus 2 plus 1 is minus 1. Right? Sorry, small mistake there. So there's someone 2x. We add 1 to the power, so we get minus 1. And then we divide by the new power, which is minus 1. Right, now, I think before, I'm going to try to clean up this here before we move on, because how we have a minus sign underneath here and a power minus 1, and nothing is mathematically wrong with that, but it just looks a little bit too complex. So let's put the 3 and the 0 here. First things first, I don't like this negative power. Couldn't I just throw the x underneath and the -1 will change to what? +1? So I think we should do that first. So if you throw it underneath, you'll get x to the power +1. Another thing, x to the power +1. Do we even need to put that 1? Isn't the 1 understood in any case? So I'm going to erase that 1. And how much is -1 multiplied by x? Won't that just be minus x? So why even put all of that? And you can just put minus x here. So that's my advice, and simplify it first. So what we're going to do now is throw the 3 in. By throw the 3 in, I mean replace all the x's with 3. Then replace all the x's with what? 0. And let's see what we get. Right. So you're going to get 2 divided by x. You replace the x here with what? 3. You must put a minus sign after. And then 2 divided by -0. Now, I think this question had a mistake in it. I'm going to explain why, right? Remember, I made up this question, so I probably did something slightly wrong. Does everyone agree with everything that I have so far? That there should be nothing wrong so far. Okay, There should be nothing wrong so far. Let me know if you agree with everything that I have. Sorry, wrong. Good so far? All right. So here's the slight mistake when I was making the question. 2 divided by minus 3 is minus 2/3. But I know try 2 minus signs here will give you a positive. So you end up with 2 divided by 0. Take 2 and divide it by 0 on your calculator. Tell me what shows up on your calculator. It's an error, right? Anything divided by 0 is actually infinity. So I made a slight mistake, right? I wasn't supposed to put 0 here. I was probably supposed to put the number 1 or something. Okay. So my error, but once you get the minus 2/3 and you had this line, you were on the way to getting it correct anyway. All right. Right. So how much people got this one correct? Yeah, I'm not asking you to know that 2 divided by 0 was infinity or would give you an error on your calculator. I know most people just assume 2 divided by 0 was 0, right? But you're supposed to get infinity or error 2 on your calculator. All right, so I made a mistake. Next time, for next year, for the people who are doing this slide, instead of 0, I'll put another number like 1 or 2 or something like that. Great. So let's move on to the, sorry, I'm rushing you all. Take a 20 seconds. So we'll move on to the next question. Let's try this question now, right? This is what you're more likely to see in the exam. So we're integrating what's inside the brackets first. So we get an x to the power 4. You divide by the new power. This one here, don't integrate when the x is underneath, right? So you throw the x on top and you get an x to the power minus 2. So let me just integrate this over here. You add 1 to the power, so you get minus 1, and then you divide by the new power. Now keep in mind it already have a minus sign here, and when you integrate, you get back a minus sign. So you know the 2 minus signs are going to do what? Touch. So you're going to get positive 16x to the power minus 1. But I don't like that negative power. So this x to the power minus 1, let's just throw it underneath and it becomes to the power a positive 1. But there's no need to even write the positive 1. Everybody with me so far? How much people got this expression after they integrated? Right? Make sure you have the positive sign here, that positive here. That's what would throw off a lot of people. Right? I can imagine the amount of people that threw off, given the different answers that popped up on the screen there. Right? All right. So you put in 4 here and you put in the 2 here. So notice it have 2 sets of x, right? So you have to replace both x's with 4 and then both x's at the same point in time with 2 and put a minus sign in between them. So let's do the one with the 4 first. 4 to the power 4 divided by 4 plus 16 divided by 4. Right. We'll put this in brackets. And then we have to put a big minus sign, right? And then the other one is this, right? You have 2 to the power 4 divided by 4 plus 16 divided by 2. Now you notice how I put this whole thing in green brackets, 2 big green brackets, because this whole thing has to be minused. If you forgot these brackets, believe me, you'll get a different answer. The whole thing has to be minus. And I think in the homework videos, I was real specific about that if you have more than 1 items, the whole thing has to go in 1 big brackets. That means the minus sign gets applied to the first item, and the minus sign gets also applied to the next item, right? So let's work this out. 4 to the power 4 divided by 4. I'm going to get, I need a different color here. Again, When you work out this part here, you're going to get 64, and 16 divided by 4 is 4. So you're going to get 68 here in the first brackets. You have a minus sign, and let's see what we get here. 2 to the power of 4 is 16. 16 divided by 4 is 4. 16 divided by 2 is 8. 4 plus 8 is 12. So you get 68 minus 12. Let me see if you got it. The final answer is 56 units squared. So for the people who got 56, you all had it correct. I'm not too sure where that 29 on 3 came from. All right, so this one here now, in the homework videos, remember I told you all that whenever I have a trig function, like you're sine something or cosine something or tan something, right? And that value is x. Remember, sine, tan, and cosine are for what? Angles. So remember, when you're replacing the x here, replace it with the angles. Remember, pi on 3 is a certain amount of degrees. But if it is regular, boring x you are replacing, I mean that it's not associated with sine, tan, or cosine. You just put what? The pi on 3. Do you all remember that from the videos, like how to deal with a mixture of a mixture of trigonometry and non-trigonometry values? Let me know if you recall that from the videos, because I spent a lot of time trying to show you how to deal with that particular situation. And also, how much is pi on 3? How much degrees is that? Because that pi on 3 right now is in radians. But how much degrees is it? 60 degrees, right, Jaden? Good, good. All right, so everyone get started. I'll look out for your answers. When you integrate 3 sine x, now when you integrate sine, you just get minus cosine. So you'll get minus, no, let me put it here, minus 3 cosine x plus 2x. So you have pi on 3 here and 0. Now keep in mind that sometimes we'll need to actually put the pi on 3, or pi on 3 is 60 degrees. If we're dealing with a trigonometry function, you want to put it 60 degrees. If you're dealing with an x, like how this x here has no trig function attached to it, you have to put the pi on 3 itself. Now, most likely your answer is going to come out in terms of pi. So let's start substituting the values here. The top value first. You have minus 3 cosine. Now I'm going to put it 60 degrees here because I need the degrees there. Plus 2. And I have to replace this x with pi on 3. So that goes in the first pair of brackets. Minus, for back my brackets here, minus 3 cosine 0. Well, 0 in radians is 0 or 0 degrees, right? So it doesn't, this one here is easy. Plus 2, and you replace the x with 0. Cosine 60 degrees. Now, cosine 60 is going to give you a very nice number. It's going to be a half, right? Cosine 60 is a half. Over here, you have 2 pi on 3, which is really 2/3 pi. All right, so let me go back my brackets so I don't get mixed up. Cosine 0. Cosine 0 is actually 1 when you cosine 0. So 1 by minus 3 is minus 3. And well, 2 multiplied by 0 is 0. I'm not going to even bother to put that 0 there. So minus 3 multiplied by half is minus 3 on 2 plus 2/3 pi. Minus and a minus is a positive. Minus 3 on 2 plus 3 is positive 3 on 2. And then you have this 2/3 pi. Leave your answer in terms of pi, yeah? And it will be units squared, right? I make a small mistake here. It's supposed to be 3/2. Now, I just say if you wanted to put it in decimal, like you wanted to add up everything here, 2 divided by 3 multiplied by pi plus 1.5. If you put everything as a decimal, you will get 3.59 units squared. So I guess the examiner will accept any one of these answers because I made sure and went to 2 decimal places and everything. Right? Look for your mistakes. Let me know what your mistakes. All right, so here's another one, right? It's pi on 2 is the same thing as 90 degrees. So in case you didn't know that, pi on 2 is 90 degrees. When we integrate this, the first one, remember this is already x to the power 1. So it will be 2, add 1 to the power, you'll get 2, but you divide by the new power. And when you integrate cosine, I think you just get regular boring sign. So you get sine x. And the 2 here will cancel out, right? You have a 2 on top and the 2 underneath. So we should probably just cancel out this 2 with this 2 one time. Put this over here. Pi on 2 or 90 degrees, depending on how you want to use it. And then you have 0 here. Let's substitute in the values and see what we get. Substituting pi on 2 first, so it's pi on 2. That whole thing, I should probably get some different colors here because it can get confusing. And the first pair of brackets, I should put up big brackets here. Then you get what? Pi on 2, that whole thing is squared, plus sine, and we're replacing this x with 90 degrees. Close the brackets, put a minus sign, open brackets, replace all the x's with Mr. 0 here. 0 squared plus sine 0 degrees. Looking correct so far, guys? How are we looking there? All right. I think I have everything correct. If you see any mistakes, feel free to let me know. So pi on 2 squared, now I think I'm not going to have a choice but to work out the decimal form here because I don't want to put pi squared on 4. That would just look too odd. So pi divided by 2, and if I square that, I am going to get 2.47 plus sine 90 is 1. I'm sure about that. And everything in this bracket is going to boil down to 0. 0 squared is 0, and sine 0 is 0. So this bracket is pretty much useless. So I think the final answer is going to be 3.47 units squared. Well, if you want to leave this here as pi squared on 4, right? Or, nah, I think you should work out that. If it's pi on, if you leave it as pi on 2 squared, now let me just give you the question here, right? Think about what you would want to see in your final answer. If you leave it as pi on 2 squared plus 1, yeah, I don't see the examiner making a big fuss out of that. I guess if I were an examiner, I would give you the full marks. All right. I can't say what your particular teacher or examiner will say. Right. Right. So, let me put back the final answer, or the other answer was 3.47 units squared. Right, for those who got it wrong, let me know that you All right, so. All right, so in this one here, I'm going to work out this one for you. I just wanted to show you all a concept that's going to be very, very useful later on. Whenever you are integrating, you'll notice that there's a constant here, 3x squared. Only if it's a constant, you can pull it outside the integration sign. So if I pull this out, you'll be left with x squared. But you could only pull out what? A constant, right? Which means if you had this also, like if you had the integral of 4, 2, and you had 2x to the power 3 minus, let me say 10x, and you were asked to integrate this entire expression, you all could pull out a 2. Now, if you're pulling out a 2, when I say pulling out a 2, you're factorizing out the 2. So you could also do it in a case like this. You could pull out the 2, so it's outside the integral brackets, and you'll be left with x cubed minus 5x. Which sometimes makes things easier, because when you factorize out the 2 or factorize out something, what you're left with looks a little bit simpler. So it makes the integral part a little bit easier a lot of the times. I'm not too sure if that was discussed in the videos, the homework videos, but if not, I'm letting you know now. So what you could do now, you all could integrate this part and work out this part. And when you work out this part and you minus it and you get your final answer, whatever you get, multiply that final answer by 3, and then the question is finished. Do you all think you all can take it from there? Now, you don't have to factorize it. It's just I want you to factorize it today because it's going to play an important part later on. The factorizing doesn't always make it easier, just sometimes. Right? So finish off the question from there, please. Right? Because when you integrate this, you're going to get x cubed on 3. Put your big square brackets here. You get 4 on 2. So you get 4 to the power 3 divided by 3 minus 2 to the power 3 divided by 2. Right. Right. Work that out. Running out of space, so let's move it up here. You're going to get 64 on 3 minus, does not make a small mistake, I make a small, there's always be a 3 underneath here. Divided by 8 on 3. 64 on 3. You're going to get 56 on 3. Well, for this part here, you're going, for this part here, when you work it out, you're going to get 56 on 3. But remember, when you get your final answer, you still have to multiply that final answer by the 3 weighting on the outside. And the 3 will cancel out to give you 56 units squared. All right, so this one was pretty simple, right? So, but keep in mind that sometimes factorizing out something could make the entire question easier. Right? Quick question. If I did not factorize out the 3, suppose I left the 3 inside and I integrated it normal, would I still have gotten the final answer of 56? Would I have gotten the same answer? The answer, right, correct, is yes, right? So whether you factorize or not, you're going to get the same answer. So let's move on to the next question now. All right, so see if we could do this particular question now. I have to read it too. They want you to prove that if you differentiate this, you will get this. That's the first thing you want to do. So the first part of the question is a differential question. So let's start you off with this here. So y is equal to sine x divided by 1 plus cos x. Because when you differentiate this, you're obviously going to get dy dx. Which rule are you going to use from differentiation? The product rule or the quotient rule? Do you all remember? Turn back in the notes. When you have a division, a top part and an underneath part, do we use the product rule or the quotient rule? Right, definitely the quotient rule, right? So the top one is always the u, the underneath one is always the v. In case you can't remember the quotient rule, dy dx is equal to v multiplied by du dx minus u multiplied by dv dx. And that whole thing is divided by v squared. So take it from there, and when you differentiate it and simplify it, you're supposed to get this answer. So the examiner is giving you the answer to work towards, but you just have to provide the working to back it up. So the top part is u, the underneath part is v. When you differentiate u and x, you're going to get what? Du dx, which is, when you differentiate sine, you just get positive cosine. Now, it's real easy to mix up differentiation and integration rules, so it takes a lot of practice. And if you differentiate the v and the x, dv dx, when you differentiate 1, you will get 0. And when you differentiate the cosine, you get minus sine. Right? Right. So let's substitute in everything here. V is how much? I'll erase the v and I will put 1 plus cos x. Right, so I should write this a little bit better. Right, 1 plus cosine x du dx. Let me erase the du dx. Du dx is cosine x minus u. How much is the letter u? You're going to get sine x. And dv dx. dv dx is minus sine x. And then we have to put v squared underneath here. Oh God, this is going to be crazy. V squared. Everybody with me so far? How much people have up to there? They should have something close to that, right? You're just differentiating and substituting it in. So let's work out the top. You gotta multiply out these brackets here. Every one inside here gets multiplied by cosine. So you get cos x plus cos squared x. Sine multiplied by sine, and you have two negatives. That's positive sine squared x divided by 1 plus cos x squared. Now you're going to immediately see something here, right? Remember from trigonometry, cos squared plus sine squared is boiled down to how much? Well, what can you replace cos squared plus sine squared with? That came in trigonometry, right? Christian, correct. Sadiq, correct. This whole part here can be replaced with 1. Okay, so what you're going to end up with is cos x plus 1, or you can put it the other way around, 1 plus cos x. It doesn't really matter. 1 plus cos x. And look at it, underneath, you have 1 plus cos x squared. Obviously, it's the top and underneath are almost the same, except the one underneath is squared. So one of this will cancel out with one of that underneath. And won't it leave you with the expression? Won't it leave you with 1 divided by 1 plus cos x? So look at it. We proved it, right? When you differentiate this, you do get this. But that's only the start of the question now. Now they want you to integrate this expression. So take a few minutes and think about it. So the way to proceed with this question, right? You have to realize it's a reverse question. If you differentiate it, you will get this expression. But if you integrate it, you're going backwards. So that means if you integrate 1 divided by 1 plus cos x, you would get back this original expression here. But we have a little problem, right? The examiner is not asking us to integrate this expression. It has a slight adjustment. They're asking us to integrate 6 divided by 1 plus cos x. It has, instead of a 1, it have a 6. But couldn't we factorize out that 6 and put it outside? And if we do that, then we get what? This expression here. And now everything falls into place. Remember, pi on 4 is 45 degrees for those who couldn't remember the radians. So that means if we integrate this portion by having the 6 outside, we will get this. We will get 6 big square brackets, and we will get what? Sine x divided by 1 plus cos x. So we don't actually have to integrate it. We have we have 2 things connected here that tells us what we will get if we differentiate or integrate each one of them. And now we can put what here? The pi on 4 and 0. And of course, the pi on 4 is 45 degrees if you're using a Triggs function. So work out the square brackets, and whatever you get for your final answer, multiply the final answer by 6. Okay? Right, so that's working out this square brackets part here. You get sine on 45 by 1 plus cos 45. You put that in brackets, minus sine 0 divided by 1 plus cos 0. This brackets could be easy here, the second bracket, because sine 0 degrees is 0. 0 divided by anything will give you 0. So I'm pretty sure that this brackets here will boil down to 0. You just need to work out this brackets out. Sine 45 divided by 1 plus cos 45. $2.49, Jaden. Again, something slightly different. Inside here, I mean, I work this out straight on the calculator, right? And I get in 2.41. I don't know if anybody else could agree with that. I would type it in like this on the calculator. Sine 45 divided by, but don't make the mistake and put 1 plus cos 45. Huh? The whole underneath has to go in brackets because you're dividing the top by the whole underneath. So you have to put the whole underneath in brackets. Otherwise, the calculator won't figure that out, right? But when you're typing this, I get in 2.41. Anybody else could confirm that? All right, so 2.41 minus 0 is 2.41. But when we worked out the square brackets, we get 2.41. We still have to multiply that final answer by 6, and then we're finished. And when we do that, our final answer is 14.46 units squared. All right. All right, guys, I won't torture you all too much.